Now let's look at some basic operations with generating functions. So suppose we have two ordinary generating functions, a of x and b of x. And so the first operation we're going to look at is addition. So if we add two generating functions, then we simply add the coefficients term by term. So that's quite simple. So adding generating functions just corresponds to addition of sequences. Now the product is a little bit more interesting. When we multiply a of x times b of x, the coefficient of x to the n can come from many different products, right? So you could have a0 x to the 0 from a of x and bn x to the n from b of x. You could also have a1 x to the 1 from a of x and bn minus 1 x to the n minus 1 from b of x, and so on. And so the coefficient of x to the n, let me write it here, it might seem a little bit more simple. So the coefficient of x to the n is going to be this sum over here, all the way to an b0. So if you think about this, a0 has an x to the power of 0 and bn has an x to the power of n. So when you multiply these two, you get an x to the power of n. a1 has an x to the power of 1. bn minus 1 has an x to the power of n minus 1. So when you multiply those, the x also becomes n. And so this gives you all the ways that you're going to get an x to the n. And this sum here is exactly this over here, right? So like you start with 0 here and n, so 0 and n, and then k grows, you get like a1 and then n minus 1, so a1 and n minus 1, and so on until you get to an b0. So that's just what it's writing there. And so this operation here is called the convolution. And so multiplying generating functions corresponds to convolving the coefficient sequences, right? Let's use convolution to find the coefficients of f of x equal to 1 over 1 minus x squared. So this is going to be the generating function of something. So let's find what that something is. So let's first observe that 1 over 1 minus x squared, you can write it as this product here. And each one of these, we know already what it's the generating function of, right? So this is just the summation of x to the n, and this is just the summation of x to the n. So now, if you multiply these two together, you can do that by the convolution rule that we just saw, right? And so now it's just going to be a summation of k equal to 0 of the terms of the ai's and the bn minus I. But here they're all 1, and here they're all 1, so it's just going to be the summation from j equal to 0 to k of just all 1s. And so this is just a summation of k plus 1 values, so you just get summation of k plus 1 x to the k. And so this means that ak is just k plus 1. Or in other words, this function here is the generating function for the sequence ak equal to k plus 1.